In question number 2, letter D, you're probably noticing it's not quite the same as letter C because of the way it looks. T of n equals 29. That 29 is not in the parentheses where the n is. So think logically about this. And I'm going to refer back to my table for a second. We really only have 2 options when we think about this table. It's either a number in the first column or the first row, or it's a number in the bottom row. So 29 is either at the top or at the bottom. The top numbers are all the n's. And it looks like 29 can't be an n because if it was, it would be in the parentheses. So by default, that means 29 must be a bottom number in the table. 29 must be like the answer to something. And we have to say to ourselves, okay, well, if we were in the bottom row and getting a 29, where in the table must we have been? If you want to think of it this way, we could always extend the table and see how far we have to go to run into a 29. So let's think. Remember the pattern in the table is adding 5? So plus 5 is 4, plus 5 is 9, plus 5 is 14, plus 5 is 19. So let's do another one. Plus 5 would be 24. That would be the 5th term. Plus 5 again is 29. And hey, 29, that's the one I needed. So the question says, if t of n equals 29, what was n? Well, it looks like if I kept the pattern going, 29 is the 6th term, so n, top row of the table, n must have been 6. So this question is really just saying, if one of the terms in your sequence is 29, which one? Oh, it's the 6th term. That's kind of all you had to think of. Some people would have used the list. They would have just kept the list going, 19, so the next term, the 5th term would have been 24, and the 6th term would have been 29. You can think of it that way as well. Now, other people are still thinking about the equation, which I think is a great idea. You could use the equation for this as well, if you want to. If you wanted to use the equation, and I'm going to copy out my equation again, t of n equals -1 plus 5n, that's my answer from the previous question, you could make a substitution. If you're not sure what I mean, think about this for a second. T of n, that's this part here, equals 29. So that means wherever I see t of n in the equation, I can replace it with the number 29. Notice the t and the n both kind of go away. It's like a 2-for-1 substitution. I can replace the whole thing with the single number 29. And if I replace that part of the equation with 29, but I don't change anything else, because I don't really know what n is, so I can't substitute that, think of this and let your algebra brain kick in. This looks like an algebra equation. In fact, this looks like an algebra equation we can solve. Let's think of it as if we were getting n by itself. To get n by itself, I'd need to get rid of this -1. I could add 1 to both sides. So I'd have 29 plus 1, which is 30, equals, those cancel, 5n. And if I try to get n by itself, I'd have to divide by 5. 30 divided by 5, well, that's 6. And sure enough, that's the same answer that I knew from the table. So remember that whole idea that you can either use the table or use an equation to help you figure things out? That's kind of what's happening here. You can either use the table or the equation in order to answer all of these questions. So in letter E, you'll have a judgment call to make again. Letter E says, if t of n equals 114, so now you have to ask yourself, what's the most practical way? Is it practical to keep your table going until you finally hit 114? Is it more practical to plug 114 in to the left part of the equation and solve it like an algebra problem? I'll let you be the judge of that because everybody's definition of practical can be kind of different. Some people think that it's more practical to do the table, that it's tedious, but to them it's easier. Some people have good algebra instincts. So to them, it would be easier to say, well, 114 goes into the equation for t of n equals -1 plus 5n. They just copy the rest of the equation, and they just solve it like an algebra problem. You decide. Both ways will work. You decide which way works better for you. In any case, make some sense of all of this, because your next order of business is to try question number 3 on your own. If that sounds intimidating, try not to let it be too different than question number 2. Many of the questions are exactly the same. Notice arithmetic or geometric, same as letter A. You have an example there of what to think about. You can rewind these videos to go back and figure out how we figured these answers in the first place. Write an equation. We have an example of that. Find the value of each expression. It looks just like letter C. T of 0, T of, ooh, this 7 is now a 6, but that's okay. We can figure that out. This 20 is now an 11. That's okay. We can figure that out. We can definitely figure out these details here. So, try question number 3 using question number 2 as your guide. You can also use the answer key as your guide. So definitely take some time to kind of go back and forth. And once you feel like you understand how this is going, then you can move on to the next page where we're going to try to tie the ideas together.